Hello, I'm Alper Adak, and I'm a PhD student at Texas A&M University in the Department of Soil and Crop Sciences. What I'm going to show you today is GGPLOT and some code in the GGPLOT to make box plot and the line plot in general. And I'm going to start with the base code, and as we proceed, I am going to show a little bit more advanced and the complex code. Hopefully, these are going to be helpful for you to make your own visualization in the near future. So before we start, you need to install the Outlier package and the ggplot2 package. I have already installed, so I am passing these two steps. And after we install the package, we are going to use the library function to open them. Before I start, I would like to tell that I use these two websites to get many of these codes, so you can go and see the other many example, really nice example in this website. So today we are going to use the truth growth data, which is available in this package, in ggplot and Outlier package. And before I start, I would like to show what kind of data set we are going to use for the basic codes. So LEN, this is what we are going to use on the y-axis always. This is what we are going to use on the x-axis always. And SUPP, we are going to use this column for grouping. So before we start, we always should look the structure of the data. So as you see, LEN is a numeric variable. So this is what we need. We need to use y-axis as continuous, of course. SUPP is a factor. So this is what we need as well, because we're going to use SUPP for discriminating the every X unit into the group. These are the group function. These are the SUPP is what we need to use for grouping. So these needs to be the factor. So when it comes to those seems numeric, but we want the those as factor. So in order to make the those factor like SUPP, we need to write truth growth, $, and then, okay, let me do truth growth, $, and we need to choose the those, and then arrow, and we need to write as factor, and truth growth again we need to choose the those. When we run that, and if we look at the truth growth data again, and we are going to see that those is factor right now. It was numeric before, but now it is factor. So now we are good to go. So now we are going to use the ggplot. This is the base function of the ggplot. And then we are going to start with the box plot. So because of that reason, we just add the Geom box plot. This is the basic code of ggplot to make the box plot. And the result of this code is going to be P. So in the following code, every time we are going to run the code and we are going to get the results. So we are going to assign the result as P, and we are going to check the results. This is what we are going to do always. Like run the code, get the results, and visualize to get the figure to see what we did in each step. So let's run the code. So, and then P is our output, and let's see the P, and this is very basic box plot. And on the x-axis, what we discussed before is the dose, and dose contains 3 different category, and these are 0.5, 1, and 2 as factor, because we made them as factor. And the y-axis is the continuous variable, and these are the results, box plot results for each like category in the x-axis. Sometimes, I mean, you would like to flip. So this is what you need to do. You just add core flip function, and y-axis is in here right now and x-axis in here right now. And we flip the box plot. And let's continue. I just add notch equals true. So in this case, we change the shape of the box plot. Sometimes you can present your box plot with different appearance. And sometimes outlier is important to present for your data. And in this case, you need to add these three parameters. These are outlier, point, color, outlier, point, shape equals a number. In this case, each number like from 1 to 24, 25 something, I can't remember. These are representing different numbers. In this case, 17 is, as you see, the triangle, and blue is a blue. So you can change the, for instance, let's say red, and so it became red. Let's say 19, and it became like round shape because 19 is round shape in this case. And let's make it a little bigger, like let's say 6, and so the round shape became a little bit more bigger. So you can play around all of these things when you want to present your outlier. So in the following card, you can add the mean value. So in this case, this lateral line inside the box plot are representing the median, and you can add the mean as well. I just exaggerating here, but you can decrease the size, like say 3. So, and then also you can change the color as we did in here. You can change the shape, and you can do the same thing for this code as well. So sometimes you would like to just pick 2 units on the x-axis, and you can remove 1. In this case, you need to write whatever category you would like to represent inside the limits equal C, whatever you want to use. So you need to use the scale X discrete code for that. So let's run and see. In this case, 1 was removed. So we have only 0.5 and the 2 category on the y-axis. And you can do these things, like let's change 1. In this case, 2 was removed. So, and you can add your every data point inside the box plot like that, or like that. There are 2 options. Each way have different like style to present your each data point. So you can use whatever you want. This one, the first one, and this one, the second one. So one of them is called Geom underscore dot plot, Geom underscore jitter. So you can use whatever you wish. So you can change the again shape, like let's say 17. So round shape change as like triangle. And also you can arrange this number, like if you say 5, the separation of point or triangle in this case became wider, and if you decrease, it's going to be like narrower. So now we are going to add color equal dose. This is the new addition as compared to base function in here. Remember, we just run the base function. Now we are adding the color in here. This is just the new addition. So remember, this is our data, and those, we have 3 different doses on the x-axis, which are 0.5 in here. I can show from here. 0.5, 1, and 2. These are going to have a different color when we add this one, because we would like to have, we are saying the code that we would like to have a different color for each dose on the x-axis. This is what that means. So when we run, P is the output of this code, always. And then when we get the results, this is what we can get. So size, you can change the size of the Geom box plot. I just put size equals 1. and let's say 2, for instance, the box plot became a little bit bigger. So you can play around this size as well, of course. And then you can change the color. This is the color. If you don't set, these 3 color options are given by the GGPLOT to you. But if you would like to set your own color, this is what you need to write. Just copy and paste and add on the P. This is the output of this code. So when we run this one, as you see, this is gray, the orange, and blue. So these codes, there are many codes. There are many codes of the colors on the web. You can search on the web, you can copy and paste in here, whatever code you want. If you would like to write the code, you need to have a unique values. This is the, for instance, value of the gray. So dash 999 and 9, loss of 9. And if you would like to get orange, dash E69 and so forth and something like that. So you can find the code for specific color that you would like to use, and you can copy and paste in here and change and get the results. Or there are really nice color palette that contains really nice combination of colors, so you can use them directly. So dark tree is one of them. So in order to do that, you just need to add scale color brewer. So just copy and paste and go to website, go to like Google and search the color palette, and dark tree is just one of them. There are many others. So personally, I like dark tree, so you can use this one. For instance, first 3 color combination of dark tree is this one or this one. So you can set manually, or you can use a color palette. I just would like to show these 2 ways to you. Or you can use, of course, to change the background color. Like you can say theme dark, for instance, and you can use gray. Maybe I can separate these 2 first. So for instance, if you would like to use just gray color, so these are black and the different gray tones. And also you can use the black background color, so dark background color, so you can do like that. So P always is the output of this one. Please remember that. And now we are going to change the inside color of the box plot. What you need to do is, again, this is the base code, and we add this is the base code of the GGPLOT. This is the truth growth, x-axis is dose, y-axis is length, and then fill. We are going to put the color for inside box plot. So when we run that, we are going to see that this is the inside color of box plot. So because of that reason, we need to use the fill function, or we can use just one color for each. If you would like to use different color for each box plot, you need to use a fill equal dose, and you need to put that inside the main GGPLOT function, like what we used before. So, and now P is going to be the result. This P is going to be the result of this one right now. So when we run this code, we are going to get 3 different colors. Now this is the P is going to be the result of this code. As you see, we have the 3 different colors for each box plot inside of each box plot. This is slightly different than what we did before. And then again, you can set the color manually, or you can use the color palette. Like we used the dot 2 previously, now we can use the accent. This is one of the different ones I just put as an example. And so you can use a theme classic to make the background like white. We used the black previously, so this is one of the another example. So as you see, I mean, if you write theme underscore, there are many options here. You can use any of you want. So these are just two examples in here. So you can try any of them, and you can choose based on what you desire, of course. So, and then scale fill gray is just one of the output that you can just use different gray tones and blacks color for each box plot to fill the box plot. And then this is the position. This is the position of the legend on the right side. And if you would like to put that on the top, just write theme legend position equals top. If you would like to put them at the bottom, this is what you need to write bottom. Or if you would like to remove, you can remove. And if you would like to change the order of the x-axis, you can write the order what you wish, and you can run. And you need to write scale discrete in this case, because what you have on the x-axis are the discrete variable. This is the categorical variable, not continuous. Now we are going to change. Okay, now we are using the sub function, which is used for grouping. So let's remember our data. We have three different columns: LEN, DOS, and the SUPP. So LEN, this is what we use on the y-axis. I'm sorry, and the DOS is used on the x-axis. And now we are adding the SUPP subfunctions for grouping. To make a group for each category on the x-axis, if you would like to use two groups for each category on the x-axis, we need to add fill equals sub. Again, we need to add this function into the core GGPLOT function. This is the core GGPLOT function, and what we need to do is just comma fills equals sub. Sub means you need to choose whatever column you would like to do a grouping, basically. So as you see, each box plot of each x unit, x factor, became 2. It was 1 before. Now each like 0.5, 1 and 2 have 2 different group inside it. So we are doing these things by adding this one. And again, we can play around, and then we can add to, again, each time. I'm sorry, you can add each data point inside each box plot by adding the geom.plot. Now, this is the end of the box plot. Again, what I showed so far, you can combine any of those at once to advance your own code and script, of course. And this is the DF2, which means data frame. So I'm just using abbreviation right now. This is the data frame we are going to use for line graph. In here, this is our title. So when we run this one, and if you look at our data, again, there is SUPP, DOS, and length. So as we discussed, LEN is going to be used on the y-axis as a continuous variable. DOS is going to be used as x-axis or as x on x-axis as a discrete categorical variable, and SUPP is going to be used for grouping. In this case, the differences is the ST. ST means standard deviation, which is important. Sometimes you need to show the fluctuation of your data point by adding the standard deviation or standard error. So let's get started. the line graph. So when we run the, again, basic GG core code, and then we need to add geom line and geom point. So when we run this one, this is the basic appearance of the geom line plot. So these are the each group, like this is basically VC or OJ or VC, and we got the line plot for each, and then geom point. These are the points that we generate by adding the geom point. If you remove that, you're not going to see the point. And of course, we can change the line type, like we can get dash, and we can change the color, and we can change the line type, which is dash, and the color is red in this case. And then size, we can change the size, like let's say 0.1 is going to be very thin. And then you can change this is the geom line. So you can change the geom line type, color, size. As I told you before, there's a website at the top. You can enter this website and you can see a variety of different line types. There's a dashed line types. There's a like 2 dashed line types. There's a plain, smooth line types, and there are many others. So you can go and check the line types that you would like to. Maybe you can use the other ones. And then color, just color. You can use whatever color you want. And size, you can change the size of the geom line plot. These are all related with geom line plot since we put all of this inside the geom line. And these are related with the geom point because these are inside the geom point code. And then you can change the color of the geom point. Of course, this is blue, like let's say green. And when we run this thing, it's only like geom point color change. And a size, and let's say 5, and it became like, let's say black, and when we run, it became black. So it's totally up to you. And now we can, now in this case, we have 2 different line type for each group, like for each group, which are OJ and VC. So if you look at this here, we write IS in parentheses line type equals sub. That means I would like to get 2 different line type for each group. And you can change the size, of course, always. And you can do the same thing for geom point. I just put these things in geom line, and that means you can like play around. You can copy this part and add inside the geom point, and you can get the different point shape for each category. In this case, what you need to write is not line type. In this case, you need to write shape equals sub, means you would like to get different shape, point shape for each sub. So you can play around. So this is what I did in the second one. So when we run this one, as you see, I get round shape and triangle for each sub. And we have 2 different color for each sub, for each group. And we have 2 different line type for each group. So you can combine these and you can use one of these based on your data. And so these are possible combination I can show you today. So for instance, this is, I guess, one of the best one. You can get 2 different color for each group, and then you can represent them with the points. These are also has the same color with geom line. So for instance, you can combine shape, line time, and color at once. For instance, let's need to add that inside the geom point. And when I run that, so as you see, Okay, let me make it like a little bit bigger. In this case, color are different, shapes are different, shape of the point are different, colors are different, and then also line types are different for each group. For instance, you can play around like that. So in this example, I'm talking about the Discord. I am going to show how you can add the Geom Error Bar. Like, remember let me show our code again to remember SD in this case, standard deviation. This is how you can add the standard deviation. You need to write Geom underscore error bar, open the parentheses. This is the big parentheses. You need to write the IS, and then Y minimum value equals LEN minus standard deviation, comma, Y max equals LEN plus standard deviation. LEN, as you remember, we are always using it as a Y variable. And then other than that, you can just copy and paste this part, all of this part basically. And then let's run and see. So this is the P is the output of this code. And let's add this one. So this is what we can get. Let me to open. Let's make it bigger. And so these are the standard deviation. Also, as you see, there's a little bit gap between each point of each x-axis, of each x category. So as you see, position dodge 0.05, these are available for Geom inside the Geom error bar and inside the Geom point. That means these are overlapping these standard deviation when they are present for each x unit. So this is why we are using the Geom underscore dodge. And these has to be the same color. These has to be the same number, which is 0.05. For instance, if I change that just 0, for instance, these are different. One of them is 0.05. And when we run that, as you see, I mean, there is an overlap in standard deviation. So let me show that like that. So there is an overlap, and which is like a little bit noisy and not nice to look at. So in order to arrange that, this number has to be like 0.05, has to be the same number in here. So, and that means the standard deviation whiskers, bars, and the Geom point have the same coordinate on inside the Geom line. And then when we run this code again, and as you see, these are feed and there is no overlap. So you can like arrange this 0.05 based on what you wish. And ABC, as you see, A, B, and C, you can check the title, x-axis title and the y-axis title, whatever you would like to write. And green and blue, as you see, green and blue, these are like a different color. You can always set manually, or you can use the color palette as we discussed before. This is the accent color. So accent color contains these two color, and then these two color combination. There are many color combinations inside the accent, but these two comes first, I guess. And so I would like to, so far I showed some basic code in Geom line and box flat. What I'm going to show in a little bit complex custom code by using my own data and to see what we can get. And this is the directory where I am going to get my data. And blobs are my name of my data. And this is how I can read the CSV file. And df is going to be my data in this case. So let's look at my data. I am going to use, so let's look at my code and figure it out which one is X, Y, and which column is going to be used for grouping and to make color. So as you remember, this is the core GGPLOT code, and X-axis in this case flight. Flight means we are interested in high throughput phenotyping in Texas A&M University. So we are conducting maze breeding research in here. So in order to capture the variation, we are flying drones. So flight means, for instance, there are 8 different flight times. These are, each one has number like from 27 to 103. And these are represented as days after planting time. So we are going to have 8 different time point on X-axis. We have D05, D1, and D2 in the previous examples data. And in this case, I am going to have 8 different time point on the X-axis. And Y equals data. Data is going to be my Y-axis. In the previous example, we always use LEN, remember? And now I am going to use data instead in my example. And then group equals pedigree. Pedigree means our plant, or if you're interested in maize breeding or plant breeding in general, these are our hybrids. So 3269 is one of parent, and 3I-6 is the another parent, and we generate the hybrids by crossing these two, and we have many pedigrees. And I would like to make grouping for each pedigrees. Basically, each line is going to be the one pedigree. And color equals yield. I am going to use the yield in here as a continuous scale, and I'm going to make each pedigrees with the different color by using the heat map of the yield value. And geom line, I'm going to use geom line, and I would like to set the size 1.2. Alpha value, I am going to arrange the opaqueness, brightness of the each line. So I just put 0.1, 0.6. You can set this color between 0 to 1, and 1 means it's going to be very visible. 0 means you can't see if you set 0. And I just put the 0.6 since I have like huge number of individuals. So in this case, in order to inhibit the overlap, I just wanted to use 0.6. This is one of the tricks you can use if you have like big data. In this case, one of the important part of this code is phase_wrap. I use traits. So in this case, I would like to call your attention traits because I have, I guess, 24 different traits. Once we fly the drones, we are getting images, as you can guess, and then we are stitching these images to like pre-process the image, and then eventually we generate the 24 different traits from these images. So that means phase_wraps and trait. Just you need to don't forget to use this sign. And then that means I would like to get geom line for each trait. Just you are dividing the geom line into how many traits you have, and we can put the title of the name of the trait on the each geom line. And when we like get the figure is going to be makes more sense. And scale equals free y, free underscore y means if we just set free, if we delete the underscore y, that means I would like to get x-axis and the y-axis unique to each trade. But if I do like that, which means y-axis is going to be unique and x-axis is going to be the same. And then n call equals 4 means I would like to see 4 columns from left to right at most. So let's run. And this is the results of this code is going to be P as usual. And then I'm just going to add the color heat map arrangement in here. So I am going to explain these things after I get the figure. So in here, let's look at, as I said to you, I have 24 different value. As you see in here, we have 24 different value in here. X-axis from 27 to 103 are the same for each 24 trades. And each trade's title in here, BGI, BI, Blue, BRVI, these are all different trades. And this is what FISET underscore rep do. And I just put this sign and trade, and then we got 24 different Geom line. And basically we got the Geom line for each trade. And as we discussed before, each line in here is the pedigree, the plant. And then these pedigrees have the different color based on their yield value, and also yield, the color has been adjusted from yellow to blue to turquoise to red. So if you ask how I adjust that, so this is how I adjust. I use the yield, as you see in here, as a like continuous heat map scale, and then I put the yellow for low value. I put the red for high value. I put the cyan color for mid value, and I adjusted the midpoint value as 10.5. And I just add this one. And other than that, just copy this part and paste after you get your results. And then this is how you can get this kind of plot. And again, you can adjust the name of the days, x-axis and y-axis by changing this part. And legend position, I just showed these things in the beginning. And this part is a part that, as you see, all the name in here are bold. So these comes from this code. So you can change this part. You can write the plain in here instead of bold if you don't want to see the bold. Or you can change the size of the title or x-axis or y-axis or x-axis, or you can change the legend title size and whatever you would like to do. You just change the number or the bold and just replace bold with plain and see the differences. So I don't want to spend time for this one. I mean, you can like play around this code a lot. So also you can change the angle. For instance, I have x-axis like from 27 to 103. Sometimes these are very big and overlap between one another. So in order to inhibit that, you can change, like let's write 45. And when you write the 45, x-axis is going to have like an ankle. It's going to be represented with the ankle. So as you see, 27, 34, 41 has an ankle. So you can change the ankle. So I'm just writing 0 right now. So you can change the angle based on what kind of data you have. And this is, I explained this part, so I have two more different example to you. This is just one of the called scale color gradient here. Again, scale color gradient. If you don't want to adjust the mid value, and you just can set low and high just, and then this is the results. I just set the red for low and high for yellow. This is what you can get. This is how you can get. Also, scale color grid is one of the another famous heat map color, and then you can run this code and I can show you what we can get. So this is the another type you can use if you would like to. So now I would like to start the correlation a little bit. So again, as I did before, I am going to start with the beginning, like the base code, and then I'm going to show one of the custom codes. So in order to do, before I start this website, I again highly recommend you to go and see the main example. Today I am going to use another my data to get the correlation matrix, and these data is inside this directory. So I am not going to run this directory again because this folder is in this this data is in this folder. So I am just going to directly read, and df2 is my new data that I'm going to use. However, this is really huge data. Let me to show this. This is the df2 data. So what I am going, as you see, there are many columns in here, but what I'm going to show, what I'm going to use is just VEG from 27 to 103 and yield. So in order to choose this part and this part, after I read whole data set, this is the whole data set, this is the df2, I am going to choose the column. This is 186 to 193, I guess. Yes, 186 to 193. This is how you can like set. That means this, I would like to get the column from 186 to 193, and I would like to add 198, which is like yielded here. So when I run this code, I am going to get only these data, this column, I'm sorry. Basically, I am doing a subsetting in here. So let's run this code. And let's look at the data. And as you see, these are the titles from, I just pick the VEG underscore 27 to VEG underscore 103. This is this one, and then I add 198. This is the yield. This is how I can get. You can, again, if you have the big data with bunch of columns, and if you would like to pick just certain columns, this is how you can get. You can do a subsetting. And then these are the code what we are going to use in the following correlation matrix. And I have already installed all this package. I am just using the library function to open them. And this is our new data, df3. This is the subset data. And I'm going to use the subset data. So I am running means matrix, correlation matrix, core function. I'm using the core function. I'm writing the data inside the core function to get the correlation matrix. So I got the M, and let's look at the M. So that means round M
comma 2 means I would like to see just 2 integer after point. So as you see, just there are 2 integer in correlation matrix. And this is my correlation matrix. So now I am going to use this matrix to make the correlation figure. So I am starting with the really like base correlations. So this is round shape. So on the far right, there is a heat map of the correlation you can look at. And this is another type of data, type of the figure of the correlation figure. And this is the pie type correlation illustration. And you can use a number, and you can use just upper diagonal only, because in this case, lower and upper diagonal are same. You may want to use just one of the diagonal instead. And this is another, just like if any correlation is lower than 0, this is represented with orange, and if the correlation higher than 0, this is represented by blue. So basically there are 4 correlation with the negative correlation, and other than that, the rest of the correlation have the correlation value that are higher than 0. So we can set the color, like there are 3 color, and these 3 color are used to create a continuous color scale, and that was like divided into 20 pieces. So when we run that, this is colony is going to be continuous color scale with 20 pieces by using these 3 color. And when we use this one in here like that, just run. Again, this is core plot. This is what we used before. I'm just adding new parameter in here. I just add this one and this one. When we run this one, as you see on the right side, there are 20 different pieces. For instance, if your like correlations varied a lot, you can use that kind of like approach to present. And now I would like to illustrate that sometimes you would like to present your correlation with their statistically significance values. So in this case, what you need to do is, this is our core as matrix DF3. This is our subset data. As you remember, this is how we subset in here. I'm using the same data set. And again, I did the correlation. This is our like correlation matrix. And then this is the, for instance, p-value matrix. Let me show you. These are the p-values between the like pairwise p-value results for each correlation. We are going to use that later. And now, again, core plot. This is what we use always. And I add the p point mat, means p-value matrix equals p underscore mat. This is what we defined in the previous code. And then significance level. You can set 0.05 or 0.01. And let's run this code. When we run this code, as you see, these correlations are not statistically significant. Other than that, these other correlations were found to be statistically significant. So you can separate which correlations are statistically significant, which one are not statistically significant, by putting the black cross like that. And again, so this is one of the, oh, let me change first the 0.01 and then let's see. for instance, these are new two. That means these two have a significance value between 0.01 and 0.05, I guess. So this is why we got these two as an addition. And in this case, you can add your significance value by doing like this, basically just for code. And we are going to use again the same p_math in here in the next code. And then significance level, I said 0.05. And just copy and run this code after you get your, of course, correlation matrix and the p-value matrix. And for instance, this is one of the like custom correlation matrix you can use. In this case, you can use a number itself, and then you can put the cross on the number, correlation coefficient number, indicating that these are not statistically significant at 0.01. Again, we can change 0.05 and okay, for instance, these are the cross on these two correlation was removed. And then this is how you can display your correlation matrix with statistically significancy informations. So this is the end of my tutorial. So if you have any further question, you can ask me, feel free to ask me. I will be happy to answer your question. Thank you so much.